in this beautiful tent. And I am most excited. I've been looking forward to this moment for quite some weeks and months. And today has been about showing practical examples and giving hope and showing that it's possible to be growing the future that we want. And somebody who is pioneering this for many years already is Dan, originally from the US, came over from Ireland this time. And I'm excited to introduce him and invite him to tell us more about soil health and nutrient density. Thank you for being here, Dan.
Thank you. All right. So I have an hour, or I'm not sure, do I still have an hour, or is it like 45 minutes now? I have a lifetime. I would presume to give like a 5-minute background on who I am, and then maybe 20 minutes or half an hour on my understandings about soil and how to work with it and nature. And then probably another 20 minutes about the research we're doing and work with the spectrometer and nutrient density and the potential for the broader movement and economic transition and things like that. Generally, I say feel free to interject with questions, although I'm sensitive to people's time, or how much time we have here. But I'll just jump into it. But feel free to engage. Okay, great. So my name is Dan Kittredge. I'm from the States. I grew up on an organic farm. A fairly small homestead mixed operation, we had animals and fruit trees and vegetables. My parents made their living running an organic farming organization called NOFA. They helped write some of the first organic standards in the United States in the 1980s. They ran an annual conference. They edited the newspaper. So I didn't only grow up on a farm homestead, but I also grew up as part of the organic movement, which is foreshadowing perhaps about what I'm going to say about organic, hopefully not offending too many people, but just sort of offering context to this larger conversation about quality and standards and labels and marketing and markets. Through my teenage years and college and then into my 20s, I managed the farm in the summertime, and then, after college, went and traveled the world in the winter and did activism. I worked on farms in Central America and Guatemala and, Honduras, Nicaragua, Siberia, India. I was a 9/11 truth activist. I worked for a presidential political campaign. Actually, the guy who's running RFK Jr.'s campaign right now, if anybody knows anything about RFK Jr., Dennis Kucinich was running for president in 2004, and I worked for him. I worked for the global anti-GMO campaign. I was the India country coordinator, worked out of Vandana Shiva's office, and documented farmer suicides, and worked with members of parliament and NGO leaders and journalists and researchers. Always trying to, in my 20s, figure out some way to actually have a positive impact on the world. And it was fighting GMOs, fighting 9/11 truth. I'm not sure if anybody knows about 9/11 truth. We want to talk about 9/11 truth. But, we got a president who could be actually an honorable president, not continuing to be causing war and all this kind of stuff. So there's lots of problems in the world, and I was trying to figure out some way to help address them. And then I found my wife and got married and had to deal with the logistics of paying the bills and raising a family. So got a little bit sidetracked from that for a couple of years. When I did get married and I decided to raise a family, I was of the opinion that if you're going to have kids, you should do it in as well as possible. And I had thought that raising my kids on a homestead, on the lands, with the parents' home, with community homeschooling and things like that was a good way to raise children if you're going to do it. Don't stick them in daycare and live in the city and have nannies and things like that. Be there, have community, have family. And so I figured the only thing I'd really done to pay the bills was farm. So I figured I'd be a professional farmer. And that's when I had my real awakening. And what sort of really directed me on this path was when I came to terms with the fact that the reason my parents couldn't make a living, and the reason a lot of people can't make a living farming, is because their plants are not healthy. People may have heard about this thing called pests and diseases. Anybody heard about pests and diseases? What's that?
Blight.
Blight.
Yeah.
Blight, mildew, corn earworm, yes. Tomato hornworm, Colorado data beetle, flea beetle, yes.
Where in the States?
Massachusetts.
Oh, fuck.
So northeast, Boston.
Boston.
Yeah. So
in the rural area of that.
Central Massachusetts. My parents, I was born, my parents were community organizers in the 70s when they met in the worst part of Boston, the sort of, it's called Dorchester, is where they met. That's where I was born, and I spent the first 4 years of my life. But my mother grew up on a farm, and she said, there's no way my kids are being raised in the street.
Fucking enough.
And so they bought, it was a dirt road, it said closed on it, half mile before you got to the house, and it was mud, and you couldn't get through, and it was like at the edge of...
Small price to pay to be saved.
Well, yeah, I mean, I was an absolute total social outcast, but some psychological and emotional traumas involved with not being normal. But anyways, we don't need to deal with that. So long story short, what I realized was, and I got brought up with this organic culture, like we're better than conventional because we don't use chemicals. Anybody have that been part of a religion or a social group that knows they're better than everybody else? Like that was my religion. We were organic. We were better people. And I knew it. That was just, it wasn't even a question. But when I realized that the reason I couldn't make a living was because my plants are getting eaten alive by pests and diseases, I thought maybe it's better not to use chemicals, but maybe there's something more to it than just not using chemicals, because all the plants in nature don't get eaten alive by pests and diseases. And so, you know, if nature's doing a better job than I am, maybe I have something more to learn. And so I started reading books and going to conferences and attending seminars, and rapidly put together some basic pieces that I had not been aware of and began to implement them. And literally, like, very small amounts of effort, very short periods of time, put the cucumbers in the spring, and they were still producing good cucumbers at frost. When the frost came in October, they were, you know, the cucumber plants were killed, but they were still eating nice, as opposed to them dying from powdery mildew after 6 weeks of harvest, or 3 weeks of harvest. Colorado potato beetles didn't come eat my potato plants. The potatoes got killed by frost. I was like, wait. I've never experienced potato plants never being eaten up by insects. I've never experienced cucumbers not being eaten by powdery mildew. There's something important going on here. And so I started, because my parents ran their organic farming organization, I was able to say, hey, I want to talk about this, and they could get me a slot at the conference, and I could speak about it. And that turned into a course, and that turned into another course, that turned into an organization. And so for the past 15 years or so, I've been teaching courses around the world now, starting in New England, to sort of spreading by word of mouth, about what I call principles of biological systems. And so that's what I want to spend the first 15, 20 minutes on here, is like, what are the basic principles that I think I understand about how nature evolved the system to work, that for anybody who's trying to practically engage in the work of, you know, growing food, these may be hopefully some insights here for you. The foundational piece I like to talk about to start with, and I don't have a whiteboard here, but that's fine. I don't have enough time to use the whiteboard. If you look around, you'll see that most plants are green. Everybody's generally okay with plants are green as a fact. You understand that they cover themselves in this thing called chloroplast, in which occurs this process called photosynthesis, which has a series of, the ingredients are, you know, carbon dioxide and sunlight and water, and the outputs are oxygen and sugar. People have heard this story, perhaps. And you know that the oxygen is emitted out of the leaves into the atmosphere. What I never learned in school, perhaps because the teachers didn't know it, was that in nature, the majority of the sugar that's manufactured in the leaf is injected into the soil. So the plants, all plants globally, cover their bodies in green to make things that they then inject out of their bodies into the environment. And we've all heard about this thing called Darwin's survival of the fittest, right? Basically, I win if you lose kind of mentality. So that's a human construct, right? Darwin was a human. I would argue that nature's been engaging a model that is not that I win if you lose model. Nature's been engaging a symbiotic model for a few 100 million years. And so foundational to working with nature well is understanding that this is symbiosis is how it works. And actually, if you look at the evolutionary biology, it's the microbes that evolved the plant, right? Literally, historically, microbes evolved plants to make sugar and feed them. And then they evolved animals to reproduce them and carry them across the landscape and spread them, right? and from an evolutionary biological perspective, they evolved us. Now, and the number of cells in your body that are human, the percentage of the cells in your body are human, is less than 10%, right? The vast majority of the cells in your body are not human. We have this, at least in the United States right now, in certain communities, all these conversations about identity. And I'm a man, or I'm a woman, or I'm not either. I'm white, I'm black, I'm purple. I would suggest the first conversation or the question might be, am I human? Because if 90% of your cells are not human, then I would argue that you're an ecosystem. You're actually a symbiotic ecosystem. You're not an animal, which are separate from microbes, separate from bacteria, separate from fungi, separate from plants. Actually, we are this, each of us, a symbiotic ecosystem, or an ecosystem, whether it's symbiotic or not, pathogenic. If you've got IBS, you got something going on in your ecosystem.
What's IBS?
Irritable bowel syndrome.
Oh, okay.
A lot of people have a hard time with their pooping, right? Their microbes, their gut flora is not healthy because of the environmental conditions, and a lot of people are dying because of it, right? Serious health issues, because foundationally they are not identifying as an ecosystem, they're identifying as a human, and this is something separate from them. So we have I think some foundational framing concepts here that can be potentially valuable if we, go through the process of thinking through it. At any rate, the central point I want to try to accomplish here is to make the point that the bottom of the food chain is the microbes. The middle of the food chain is the plants. The top of the food chain is the animals. That's how we envision it. So when it comes to producing food, being a farmer, gardener, homesteader, whatever you want to, however you want to, say you're working with the land, caretaker, steward, my position is it's entirely irrelevant whether you're producing carrots or cucumbers or apples or wheat or echinacea. The foundational point that needs to be understood is that only when the bottom of the food chain is functioning well, only when the microbes are healthy and diverse and flourishing, should you expect your plants to be healthy. So that's the central point. And then from that point we go to, okay, so then therefore, what do microbes need to be healthy? What do they need to function well? And it's actually quite simple. Microbes, among other things, need air to breathe, right? They're not all of them are aerobic, but we need this cycle of oxygen flowing through the soil for the microbes to function. So if you've got tight soil, dirt, I was just in Ireland a couple days ago, and they have a lot of heavy clay soils, and if you don't have any air in that soil, the microbes will asphyxiate, and then they'll be dead, and then your plant's not going to get fed, and then you're going to have problems. So managing the soil in such a fashion as to maintain aeration is a key piece of this strategic process. In many cases, farmers will till their soil in the spring because they understand that if you put seeds into tight dirt, they don't do very well. And I would suggest that the reason you had tight dirt is because you left the soil bare all winter. Anybody heard about this idea where farmers will plow the ground in the fall and leave it bare?
Important part of the farming process, right? Plowing.
The destructive process?
No, but that's what they have a special machine to plow the earth. And I always thought if you have a special machine, it has to be important, right?
No, but it's for conventional farming.
Well,
No, but
it's for about 10,000 years we've been doing it.
Yeah,
Ever since we started this thing called agriculture.
great invention, plow.
The great invention of civilization,
Yeah.
which was to stockpile food and have cities and then engage in war and control, right? You could argue that there's indigenous cultures globally who have not engaged in such a fashion of food production that have had the effect of building soil much more systemically than agricultural civilizations have worn out soil. You look in Egypt, you look in Iraq, you look in Syria, there's lots of places around the world where you can look and see that agriculture was practiced, and now it's desert, right? There's a city called Palmyra in the center of Syria, which is a UNESCO World Heritage Site, 2,000-year-old city, and it's surrounded by desert, 50 miles that way, 200 miles that way, kilometers, 100 and whatever. It's desert in all directions, right? And the idea is, whose brilliant idea was it to build a city in the middle of the desert? And the answer is, it wasn't a desert when they built the city. They practiced agriculture and they failed. As opposed to what was going on in Australia when the Europeans came.
Yeah.
They couldn't ride their horses across it because the soil was too spongy. It was 12% organic matter across the entire continent, right? Literally, original historical records, read them. Australia was not desertified. Australia had deep, thick, spongy soil because for 60,000 years, those indigenous people with no war had been managing the land in a very sophisticated manner. North America, when the white man first came, right? The Native Americans were a head taller than the Europeans. They were much more sophisticated. They were superior physiological specimens, right? They had been managing the ecosystem in a very strategic way with no plow, with no beasts of burden, with no, fertilizer, thoughtfully and gently working with the land to build vitality. So the point is here that we can work with nature in a gentle way to actually facilitate deep systemic benefit. And foundational to that is creating a dynamic where the microbiome is functioning well. Did you have a question? I'm sorry.
Plowing.
Yeah.
Like we started here, the logic that got explained about the plowing is
Yeah.
Holland is crazy country, right? Like with a whole man-made.
Yeah. It used to be underwater. Yeah.
So this used to be a lake.
Mm-hmm. Yeah.
-5.
Yeah.
Towards the sea level.
Yeah.
And we have clay.
Mm-hmm.
Blue clay.
Yes. Yeah.
So they said by plowing it open,
Mm-hmm.
frost in the winter can go in deep.
Yep.
And I had to admit in the beginning, if you see what frost does to this clay, compared to you trying to brittle it up like that, right? So
Yeah.
mix it with organic matter, it made a lot of sense, right? At the time, that
Mhm.
was a good way to open up.
Loosen it up.
But I don't know if this is relevant in any other parts.
Well, clay is you got sand, silt, and clay are the three sort of components of soil, except for where I come from, we have rocks. Where I come from, we have the occasional pieces of silt or sand, but mostly just rocks.
What's peat then?
Peat?
Yeah.
Well, that's straight organic matter. That was a,
Stuff.
I would say a balance is a good thing, but I mean, you've got what you've got.
But this is, we have arable land here, and it's peat that makes it possible. That's how it was explained to me at least.
Well, you have what you have.
Yeah, that's true.
And you need to work with it, right? You've got the body you've got, you got to deal with it. My mother had cancer, my father had cancer. I want a new body. Sorry, you don't get a new body. This is my property. I want my neighbor's property. No, you can't have your neighbor's property. You can't just switch. So the more you understand the dynamics of what needs to be in place, the more you can balance accordingly. And that's the principle. Is that life needs basic things to function, and so you want to manage for those things. If you identify a limiting factor, you want to address it. The point I was going to make about bare soil and tillage is that if you had kept that soil covered in the fall, I used the example of garlic. You guys, I think I saw some garlic. Well, up the street I saw some garlic, but we plant garlic in the fall. You guys plant garlic in the fall? Right, October, something like that. So we pull the carrots out. Fall carrots get pulled out. Maybe you got a 1/4 acre, and you put 1/8 of an acre. You guys don't do acres, hectares, whatever. You pull all the carrots out, and you have a smaller area that you put your garlic in. The way we do it is we mulch the garlic in the fall. After we plant it, we mulch it, and then
What's mulch mean?
it's organic material like hay or straw or leaves or seaweed or some kind of an organic material gets put on the soil to cover it. You guys don't have that. Do you guys still have snow?
I just never heard the word.
Mulch. Yeah. Okay. Anyway, what happens in the spring when the after the snow's gone and the soil's thawed out, the garlic starts growing. And if you were to pull the hay back and reach your hand down there, you would see, for starters, piles of earthworm castings. And then if you reached your hand down into it, you could pick up the soil and it would smell like soil. But if you went over 3 feet to the area where the carrots got pulled last fall and then the ground got left bare because the winter came, that soil would be cracked. It would be dry and tight and cracked. It would be dirt. It wouldn't be soil. Soil has got life in it. Dirt is not. It's tight. And so the point is, most of us like to eat most days, right? You don't usually take like 3 months off from eating. And if the green leaves are, making sugar from photosynthesis during the summertime and feeding the microbes, in the wintertime, the microbes don't go to, I don't know where you guys go in the wintertime. Turkey or Ibiza or I don't know.
Yeah, I like the pizza.
Yeah, I don't know. I say Florida when I'm in North America, but
I've been to Florida. It's great.
anyway, right? The microbes don't hop on a plane and take off to somewhere south and for the warm for the winter. They stay where they are and they need to keep eating. Is the basic point. And so if you keep the soil, if you let the soil be bare, the microbes are then, they're still alive, they're eating, they run out of food, they starve to death, and that turns into dirt. So the part of the reason why farmers till in the spring is because they kept it bare in the fall. Does that make sense? I like to say, you know, people, have you heard this thing? Do you guys say this? What would Jesus do? Have you guys heard that one? Maybe it's just a thing that happens to say in the States, the evangelicals. I like to say, what would nature do? What does nature do? Where in nature do you see bare soil? Right? Nature does not do bare soil. So if you want to think about nature as your mother and doing things that violate your mother, right? Like, think about it that way. No, don't go there? Okay. Yeah. Or nature's a woman, and it's a violation of a woman. Like, what does nature do? This is that I think we need to be operating from this perspective. How does nature do it? Because if we're doing something that's a violation of nature, we are violating nature. And that's just, I don't need to go any further to make that point. So keeping the soil covered is one of the things nature does. And so on my farm, I've got a rule. It's an internal rule. I don't have it written down, but basically I want to see my soil less than 2 weeks of the year. Like, there are some times when I'm going to be transitioning from one crop to the next, etc. But a general principle would be, I want to maintain soil cover as much as possible. And you find that when you go out and you plant your annuals and you leave it bare and you go out and you weed, nature tries to cover it up again. She grows weeds, right? She's trying to cover herself. And you're like, no, uncover yourself. So what I do is I use mulch. If you cover the soil with hay or straw or leaves or some kind of an organic material, or you've got cover crops that you've been able to integrate into your cycle, then weeds don't grow. Anybody like weeding? Some people like weeding. I've weeded a lot in my life, and I don't like weeding. I like the heat of the summer, July. I like to be swimming with my kids, taking a nap. I do not like to be out in the beating down sun weeding all day long as a farmer personally, but that's just where I'm at. Anyway, so soil life must have air to breathe. They must have food to eat. Yes?
I've seen some crops that they put plastic
Yeah.
to cover the soil.
Mm-hmm.
How does that be? Of course, it has many difference than organic matter, but
Yeah.
what are the benefits of having more organic materials covering?
So, what's the, yes, thank you for catching me. No, I'm supposed to repeat the questions, and I haven't been repeating the questions. So,
It's all right.
yeah, you've seen people cover the soil with plastic, and what's the cost-benefit analysis on covering the soil with plastic? Certainly, you're minimizing the oxidation, because sunlight on bare soil burns off organic matter rapidly. Oftentimes, people will cover the soil with plastic so they can heat it up, so they can put things in earlier, because soil temperature, because microbes actually like, I don't know what 70 degrees is. Would that be 20 Celsius? Right?
Something like that.
Yeah. I mean,
close.
if you look at in the wintertime, people will set the thermostat in their house for 20 degrees Celsius or thereabouts. In the summertime, people will put the thermostat for 20 degrees Celsius if they have air conditioning, right? There's that like comfortable zone where it's like, okay, perfect. And if it gets too hot, you don't have much energy. If it's too cold, you start shivering. It's the same with microbes. There's a magic sweet spot where they function really well. And so if you're planting seeds or seedlings into the soil in the spring to get a start on the year, and the soil's cold, the microbes aren't doing very well. And you can put the seeds into the ground, but they're not going to be fed by the microbes because the microbes aren't doing very well. So strategically, it's done to extend the season, to get things in earlier and get a longer season. So it's good to minimize the oxidation from sunlight. It also will minimize the wicking off of moisture. If you've got an issue with a drought, maybe you don't have the issue here. I guess the spring was a bit dry, but wind will wick the water out of the soil. So bare soil, uncovered, is much more rapid, will dry out. So the black plastic will benefit in that fashion. But yeah, personally, I use organic material on my farm. And I don't really use much else. I don't use compost. I don't use a lot of things. I like to use, again, the model, what does nature do? Nature takes the dead plants and drops them on the ground and digests them in situ, right? She doesn't take the plants and go over here and pile them up and turn them over a couple times and bring them back. Like again, I said, I worked my entire childhood on the farm all day long, all the time, against my will. I don't like to work unnecessarily. I like to do as little as possible, and so I just take, when tomato plants are dead, they get killed by the frost, they fall down. Anyway, digression. So air to breathe, food to eat, water to drink. Oftentimes people will water. I mean, I guess maybe it's not such an issue here. I don't know about your climate exactly, but when people use irrigation systems, they may take a line of drip tape and they'll put a line of drip tape right down the middle of the bed where the tomato plants are, because they're watering the plants.
We do that a lot in our agriculture, at least in the organized.
And
We do
so,
a lot of that irrigation.
so what I would say is, as above, so below. You want to have as much plant above ground as below ground. If you're maintaining moisture just at the point where the stem hits the ground, a good sized tomato plant, it should be 3-4 feet wide. And so if you've got powder dry dirt over here and powder dry dirt over here and moisture right here, then all the microbes in this whole area are dead. So you want to maintain moisture for the microbes, not for the plant. Again, think about the fact that we're creating a dynamic for the microbes to function well. You want moisture across the entire soil profile. So air, water, food. The microbes themselves, of course, must be there. In many cases, we have not. We have engaged in practices with tillage, with chemical fertilizer, with insecticides, fungicides, things like that, which have caused the species of microbes to no longer be present, which is why compost tea and Prairie Natural Farming and inoculants and things like that, there's all kinds of techniques, indigenous microorganisms that you can use to reestablish the microbiota. But that's also a critical component because you want to have, hundreds, thousands of different species extant in the environment. And in many cases, because of what has happened historically, they're not. And so,
Question, how do you do that on a natural way? So without bringing it from outside inside, just from inside out?
So what I would say, if you're going to be harvesting microbes from your environment to reestablish an area that is not where they're not doing well, I would like to go for a walk and bring a bucket or a bag, a little shopping bag or something like that, and I want to hit as many microclimates as possible. You guys don't have anything but flat, from what I can tell, around here. You don't have like mountains and things like that around here, but are there ridges? I've been looking for something. Yeah. I like to look. So I want to get a meadow. I want to see a forest, a stream, maybe a pond, a swamp. I want to hit as many different microclimates as possible, and I want to be looking for plants that have shiny leaves. People have heard about ever grown a zucchini plant. And you see when the zucchini plant is young, it's like growing vigorously. And it's got these nice shiny leaves. Anybody ever seen that on a zucchini plant? And then maybe it starts to set fruit and it gets a little bit hot and maybe dry. It's July or something like that, and that shiny leaf turns into just a green leaf, and then it turns into a little bit yellow, and then it turns into white, and then it's dead. Have you ever seen that shift in the color of the leaf? Do you know what causes a leaf to be shiny?
What?
Sugar?
Wax. So wax, fat, oil. Animals do this thing where if they eat too much food, they stockpile the extra food in the form of fat. Anybody heard about that one? Yeah? You know about that? It's a joke. You can laugh. All right. Thank you. Anyways, plants do the same thing. If a plant gets access to more food than it needs, it will stockpile the extra food in the form of fat and wax. So it's called a waxy cuticle. So when you've got a plant that has a shiny leaf, that means it's fat and happy. It means it's healthy, it's being well fed. So if you find a plant in nature that has a shiny leaf that's not being fed fertilizer, the only way it's being fed is through a well-functioning microbial ecosystem. So if you go out and you look for shiny leaf plants, they have healthy gut flora. So what you want to do is you want to find as many different species of plants as possible, many different families of plants, oak trees and sumac and dandelion, and I'm not sure what kind of plants you have, but you guys have similar plants to what we have, right? You want to look for as many different kinds of plants as possible, different ecosystems, and find the ones that have shiny leaves. And then you would go underneath each one of them and take a handful of soil and put it in your bucket or your bag. And then when you get back home, you add some water to that bucket, and you stir it up, and then you pour that water into your watering can or your irrigation system, and you can effectively be harvesting a broad suite of indigenous microorganisms from your local bioregion and reestablishing them into your agricultural soil. So that would be a very low-tech, simple way of doing it. I'm not saying that you should only do that. There's also some very high-quality products that you can purchase that are broad-spectrum inoculants, which have guaranteed levels of critical families which may not be present in the local ecosystem. So it's a suite. There's all kinds of different ways of doing it, but reestablishing gut flora is a really important piece of the puzzle. And in fact, I like to say, if you take, I do 2-day courses, and I say, if there's one thing you take home from this that you're going to spend 5 minutes and $5 on, I would suggest it be inoculation to your seed. There's this thing called colostrum. I'm not sure. I'm speaking rapidly in English, and I appreciate you all who don't have English as your primary language. You know what colostrum is? You don't know.
No idea.
Okay, colostrum is what comes out of the mother's breast after birth, before milk.
Yep.
So after birth, before milk, something comes out of the mother's breast, which is a prebiotic, it's a probiotic. It's there to establish gut flora, right? Because when you're born, you don't have any microbes in your gut, right? Between your mouth and your rear end, there's nobody in there living, and you can't digest your food, right? It's only the people inside of you that digest your food. You may know that one, right? We didn't talk about that, but that's kind of, yes. It's only the people inside of you that digest your food for you. If you didn't have any bacteria and fungi in you, you couldn't digest your food, right? They are the critical symbiotes, and so at birth, it's critical to establish healthy gut flora, and that's what colostrum is. And that's why dairy farmers will always make sure their calves get colostrum for a day or two before they take them away from their mothers, because if they don't, they'll die. If you have a calf that didn't get its colostrum, if anybody's ever been in a dairy barn and heard a bawling calf, have you ever heard that noise? Ma, ma. It's like a fire alarm. It gets under your skin, down your spine. You can't pay attention to anything else. It's nature's alarm system, right? A crying baby. Babies aren't supposed to cry. Crying is a sign of something being wrong. So in English we say a colicky baby. A colicky baby is one that does not have a well-established gut flora, that cries a lot, does not establish, it can't digest its food. It does not have that critical symbiosis across the kingdoms well established. It's exactly the same with plants. Plants also cannot digest their food. Plants have evolved microbes have evolved the plants, this symbiotic relationship. And so at birth, at germination, when the seed begins to grow, you want to have in contact with that seed a broad spectrum of spores of bacteria and fungi. Right, you want that that colostrum present on the seed. So what I would suggest is ensure that you inoculate your seed when you plant, before you plant. In some cases, I'm not sure what it's like here in the middle parts of the United States where people grow a lot of corn and soybeans and things like that, they're actually required to coat the seeds with fungicide, which is profoundly perverse. You have that also here?
You can choose.
You can choose. You can choose. But so coating your seed with fungicide would be like giving your baby antibiotics at birth, right? It's entirely counter to nature's system. So if your baby does not digest food very well, it's probably going to be going to the doctor a lot. Well, if your plant can't digest the soil a lot, you probably need lots of fertilizer, and then you need some insecticides, you need some fungicides. So it's really good business for the people selling products, but it's really counter to nature's way. Anyway, so the microbes themselves are a key piece of the puzzle: air, water, food, microbes. And then the final piece I'd like to talk about before I move on to the science and the nutrition density movement conversation is minerals. There is this is a piece of the puzzle that that at least in the States, not a lot of people talk about, and is a really important piece of the puzzle. Maybe I'll just use a metaphor for a second. People walked in here and saw those hoop houses out there. Has anybody ever here built a hoop house? Yes, built a hoop house. So you know that when you start with the hoop house, you've got a pile of metal pipes that is not particularly large, right? It may be whatever the meters, be 3 meters across and 1 meter wide, and it's like a pile of pipes that's not very big. And when you get done building that hoop house, you've got 30 meters long and 10 meters wide and 5 meters tall, right? It's a decent sized structure. And the only thing you did to convert that small pile of metal pipes into this big structure was you tightened the nuts onto bolts. So a 10 millimeter, whatever it is, a 12 millimeter nut tightened onto this bolt over and over again, right? To hold the whole thing together. Have you ever done this before? You just over and over again, you tighten this nut onto this bolt and the whole thing is held together. Now, that is the metaphor that I use to explain biochemistry, which is a word that sounds very complicated and fancy and sciencey, and some people get sort of, their brains sort of shut down when they say biochemistry. I think of it as sockets and wrenches, you know, screwdrivers. You guys, you know what a socket is? Spanner, they say in Britain. Yeah. Yeah.
Topsleutel.
Anyway, so you've got all these different size sockets. You've got in the metric system, we've got 9/16 and a half inch and 7/16. You've got 10 millimeters and 12 millimeters and 14 millimeter sockets. They all have their own sizes. You maybe have screwdrivers that have the Phillips head or the flat head or the star bit or the square bit, right? You've got all these different size tools that you can use over and over again to put things together or take things apart. Everybody's familiar with that concept. In biological systems, there's this thing called enzymes, which effectively are that. They are the things that are used by life to put things together and take things apart. So if you've heard of a protein, a protein, they say, is a bunch of amino acids that got screwed together to form a protein. It's a bunch of sugars that got screwed together to form a carbohydrate. So it's the enzyme that takes the sugars and screws them together. It's the enzyme that takes the amino acids and screws them together. It's also the same exact enzyme that in your belly unscrews the amino acids off the protein to make it food for you, right? You only eat amino acids, you don't eat complete proteins. They're not bioavailable. So the same enzyme is used to put things together and take things apart. And what gives that enzyme its unique size and shape, like the Phillips head screwdriver or the flathead or the square bit, is the element at the core. So there's copper-based enzymes and zinc-based enzymes and cobalt-based enzymes and molybdenum-based enzymes. There's a whole suite of different enzymes that are necessary for biological systems to function. When the Human Genome Project was being performed, the Human Genome Project, where they're mapping the human genome in the 1990s, right? They didn't just identify all the pieces of the DNA, they identified all the enzymes necessary to replicate the DNA. Right? Because DNA is a big, long compound. It takes a lot of different bits and sockets to screw it together. And once they identified all the enzymes, they were able to identify all the elements. And there's 25 different elements, copper, zinc, calcium, potassium, phosphorus, sulfur, molybdenum, sodium.
Are they mostly metals then?
They're all over the periodic table.
It's so diverse.
Required to replicate every strand of human DNA.
Fuck.
Every strand of human DNA. And that's not talking about your glandular system, your hormones, all kinds of other things that we need to function well. Just your DNA.
The base pairs and everything.
Did everybody know that they get a new body every 6 months?
Yeah.
Have you know this story? Right. Every day, 4 billion of your oldest, junkiest cells get disassembled. Salvageable parts are kept. The rest goes out the rear end. Your eyeballs, your liver, your flesh, your bones. Right? Your body is constantly rebuilding itself. Right. A mechanical system like a car might have brake pads that are designed to be taken out when they wear out, and you get new brake pads put in. Or a muffler, if it rusts out, gets taken out and new muffler put in. Like, we are not mechanical systems. We are not designed to have our livers taken out, new livers put in, our knees taken out, new knees put in. Nature evolved us to have them constantly being rebuilt. But when you don't have the full suite of elements present in your diet, at the core of the enzymes, when that DNA replicates itself, if the chromium-based enzyme is not present, the pieces of DNA that are supposed to get put together by the chromium-based enzyme don't get put together, then you've got a genetic marker. You've got a break in the DNA. So we have direct connection between chromium deficiency and the genetic markers that correlate with diabetes, for example. Right? We can see direct connection between chronic disease and nutritional deficiencies. And I like to say to most farmers, if you take a soil test and you send it into the lab, how many elements does Wageningen recommend you apply to your soil? In general, at least in the United States, it's 3. Nitrogen, potassium, and phosphorus, occasionally calcium or sulfur for pH balancing. But the conventional system is not thinking about what is grown in the soil as food. They're thinking about it as industrial product. The idea is not to create a thing that has all the things in it that our body would need. The idea is to create a volume of thing, right? There's a big problem, I would say, in the way the conventional system works, because they're not really thinking about food as food. They're thinking about food as commodity. And so I would suggest our responsibility as farmers, growers of whatever scale we are, is to understand that we should be producing that which sustains us, which vitalizes us. There's this guy called Hippocrates. You may have heard of Hippocrates, the Hippocratic Oath. Do you have doctors who have to swear the Hippocratic Oath in this country? Some of them do. Maybe some people don't know who Hippocrates was. There's the Hippocratic Oath. As I understand it, there's 3 pieces to it. The first is, let food be thy medicine. That's the third piece. First, do no harm. As in, no cutting, slicing, toxins. So that would include surgery, radiation, chemotherapy, pharmaceuticals. First, do no harm. Add no toxins, don't hurt the body. First, do no harm. Then let me not be inspired to prescribe a poison. That would be the pharmaceuticals. First, do no harm. Then let me not be inspired to prescribe a poison. And finally, let food be thy medicine. This is Hippocrates a couple thousand years ago, right? Indigenous wisdom, even from the Western culture, right? There's all kinds of indigenous wisdom from other cultures, but this might be indigenous wisdom from the Western culture, if you consider the Greeks and Romans to be Western. I'm not sure if you do or not. Actually, most of that wisdom came from India, actually, but that's a whole other conversation. So, as far as I'm concerned, this broader conversation is about food and nutrition and health. And so I'm going to modulate now from the, well, I guess I can talk about minerals a little bit more if you want before I move. I'll just do a couple of things on minerals. One of them, if you understand this concept of enzymes in biological systems, people have heard about nitrogen being a thing that farmers apply to their fields.
Important issue here in the Netherlands at this moment.
Right.
We've had protests because of the nitrogen that we want to cut, and there's been people.
I'm familiar with yeah. So, does anybody know what percentage of the atmosphere is nitrogen?
75?
78. More than 3/4 of every breath of air you breathe is nitrogen.
So I'm not breathing oxygen, I'm breathing nitrogen.
Yeah.
Well, 21% is oxygen, 78% is nitrogen, and 1% is everything else. So the basic argument here is that there's plenty of nitrogen in the environment. And the next question is, how many of those trees over there are legumes? Actually, I see a legume right there. But most of those trees over there are not legumes. So who's adding nitrogen to that area? Is anybody putting fertilizer down, compost down over there? Right. In large parts of the world, things grow just fine that are not legumes with nobody adding nitrogen fertilizer, because nature evolved a system to harvest the nitrogen from the atmosphere to feed plants. And it's through this thing called a nitrogenase enzyme. And there's all these different microbes who have evolved symbiotic relationships with every species of plant 300 million years ago. The microbes are there. They use the enzyme to grab the nitrogen gas out of the atmosphere and turn it into a plant available form. When the scientists, however many years ago it was, found these little white nodules on legume roots and said, oh my God, legumes fix nitrogen. That doesn't mean that corn doesn't fix nitrogen, or tomatoes don't fix nitrogen, or apples don't fix nitrogen. It just means that they don't have nodules on their roots. So there was a Russian microbiologist by the name of Krasilnikov who, I think it was 1970s, had identified that every single family of crop plants globally had symbiotic relationships with nitrogen fixers, foundationally evolved. So another rule on my farm is thou shalt not add any nitrogen. I don't add nitrogen. I don't use fish, I don't use blood, I don't use compost. If I can't harvest, if I do not have a system functioning on my land where my plants are harvesting nitrogen, then I don't deserve to take those crops to market. That's one of my little head trips. There's this element at the core of the nitrogenase enzyme, which is called molybdenum. Molybdenum. Molybdenum is an element on the periodic table of elements, which is the center of the nitrogenase enzyme. And you need about 1 kilogram per hectare in your soil of molybdenum to have all of the nitrogenase enzymes you would need for whatever crop you're growing to fix all the nitrogen it would need all year long, right? So that's an example of an element that is not oftentimes recommended. Sorry, that's my phone. Not oftentimes recommended by Wageningen or anybody else, but would, if you had a functioning biological system, create a dynamic where you would not need nitrogen, period. Not need to add it because it's already naturally cycling.
Do you add molybdenum sometimes then?
So what I would recommend as a farmer, among other things, to farmers, along with adding inoculants and keeping your soil covered with mulch or with cover crops and minimizing disturbance and maintaining hydration, is to address mineral deficiencies. I'll just do another example of another element is cobalt. Cobalt's the center of this compound called B12. People may have heard about B12 if you're a vegetarian or a vegan. Oftentimes your doctor will tell you you need to supplement your diet with vitamin B12 because you don't get enough B12 in your plant-based diet.
But possible then, in your plant-based diet?
Well, it's entirely possible, but the problem is you're eating the product of conventional agriculture, which is devoid of all kind of nutrients, because Wageningen is only recommending NP and K. Because Wageningen only recommends not NP and K, you don't have the boron and the sulfur and the molybdenum and the cobalt and everything else in your system, which is why you have chronic disease. You got diabetes, you got cancer, you get heart disease, you get, all these osteoporosis, these chronic diseases connect directly with nutrient deficiencies. Let me just finish cobalt for 1 second. Oh, no, I guess not.
Sorry. To my idea, it's all in the soil because
Yeah.
it's only not plant available. Is that true? Because it's all there. Everywhere in the world, it's all there. The only problem is that it's not plant available because of the microbiome of the soil that's not functioning as it should be.
I would say that if you look at a sand dune, you're not going to find a full spectrum of elements present. That there's this woman called Elaine Ingham. Anybody ever heard of Elaine Ingham? Soil Food Web.
Yeah.
She's famous for this statement that all the minerals are present in the soil. You do not need to add any minerals. She came and spoke at our conference about 5 or 6 years ago, and I've been recommending minerals for a number of years because on my farm I experimented with things like rock dust, like granite and basalt and sea salt, literally sea salt and granite dust. Nothing, not fancy things like cobalt sulfate or sodium molybdate. And I found
simple stone.
and I found amazing things to happen. And so, and my experience has been with other farmers, when they add some simple things like rock dust and sea salt, they get amazing things to happen. And so I questioned Elaine Ingham on this very topic, and she said, in the top 24 feet was her caveat. So anybody who's ever heard Elaine Ingham say, all the minerals you need are in the soil, in the top 24 feet of the soil. So if you've got a well-established perennial polyculture with tall trees reaching down 24 feet, that's 8 meters, right? Then yes, you have the full spectrum of minerals. But my point is, when you put a seedling into the ground or a seed into the ground, and you've got soil that's been abused for historically, it's entirely possible that you do not have that full spectrum of elements in the region where you have that baby going through early childhood development, needing optimal environmental conditions. And so from my perspective, adding minerals is a very important piece of this puzzle. If you've got a full spectrum of minerals, that's fine. You don't need them. That's why you take a soil test. But the point about cobalt and B12 was that you need B12 to function. If you don't have enough, you become anemic, you become lethargic, and if you really don't have enough, you become dead. Now, B12 is a compound at whose center is this element cobalt. So you're actually a cobalt-dependent organism. If you don't have enough cobalt in your body, you're dead. You need cobalt. Now, 80% of the species of soil life that have been studied, which is a far range from all of them, but of all the ones that scientists have studied, 80% of them are cobalt dependent. They need B12. So if you don't have B12 in your soil, you can add all the compost tea, you can add all the inoculants you want, but with no B12, they die, right? The microbes need the minerals to function. And the same biochemical pathways that the microbes use, the plants use, and the animals use. So ensuring a broad spectrum of elements in the environment is a very powerful piece of this puzzle as far as I'm concerned. So those are the 5 things I like to talk about. Maintain sufficient aeration, hydration, food, microbes, and minerals. And in my experience, if you do those things, if you address deficiencies, if you say the soil's too dry, I'm going to keep it wet, the soil's uncovered, I'm going to cover it, then nature will, in my experience, do most of the work for you. And that's what I like.
Aeration, hydration?
aeration, hydration, food, minerals, and microbes.
Minerals, like you can do an EC test, right? The electric conductivity of your soil.
Yeah.
Is that related to that broad range? Because usually there's trace salts, right? Nitrates and these things, but all the ones you mentioned are electric conductivity.
If they're in ionic form, but nature doesn't necessarily do ionic minerals. Nature does sort of like amino acids and much longer chain compounds. So an electrical conductivity meter is a very valuable tool for assessing in-season level of energy. And then you can modulate accordingly. I wasn't going to get into that right now because I don't have my 2 days that I usually take, 12 hours. The speed at which I'm speaking, I usually speak for 12 hours to cover all the how-to. I'm just giving you a total, like, the high level. But there's this thing called YouTube, and if you type in my name and you go to YouTube, you'll find a much longer version of this presentation. Hopefully you're just being inspired to some degree. But I do courses, and anyway, we'll talk about that in a minute. I want to get to the nutrient density and the meter and the science piece. So I've done introduction, I've done agronomy, and I don't know how much time I've used, but you guys all look like you're paying relative attention, so I'll just keep going until people have to pee. All right, so anyway, I started this project with this workshop and these courses, and it kind of spread around. And I live in Massachusetts. We call that New England. It's part of the northeast part of the U.S. It gets kind of cold. It's pretty rocky. Somebody from New York heard me speak, said, "Well, come to New York." And then somebody from Colorado heard me speak and said, "Come to Colorado." And somebody from California heard me speak, "Come to California." And so I began giving this presentation in other parts of the country, and then Canada, and then Ireland, and then whatever. And wherever I went, different soil types, different climate zones, different crops, these principles seem to work. It seems to work regardless of what the area is. In California, it's too dry. They don't have enough water. They don't have enough soil cover. They got plenty of minerals because it hasn't, there's not enough water for them to leach out. Where we live in New England, it rains, 100 millimeters a year or 150 millimeters a year. Things leach out. Things like sulfur and boron, molybdenum are anions, and when it rains, they get leached into the subsoil. So we have mineral deficiencies, they have water deficiencies. And so the issue is to identify your deficiency and address it. But if you do that, the experience has been soil gets built. And one other piece of this puzzle, I talked about pest and disease resistance. There's this thing called, it's called complexing of compounds. Complexing of compounds. So you start with sugars and then you turn them into carbohydrates. And you have amino acids and you turn them into proteins. So I use a metaphor to convey this point, which is that if, when you all came to sit down here, perhaps there was a bale of hay. Remember in the olden days we had square bales of hay? Not just round bales. Remember those days? This like the square bales are gone these days, but imagine there was a square bale of hay that you could easily sit down onto. I mean, you might have sat down onto it, you probably would not have eaten it, I'm guessing. Most people would not consider a bale of hay to be food. And yet if you'd walked a cow in, that cow might have said, "This is food to me," and not considered sitting on it. And we're all pretty much comfortable with that statement. But what that means is different organisms have different levels of digestive system function. Right? A cow can digest hay, we can't. Okay, fine. Well, larval forms of insects can't digest protein. They don't have a liver. They don't have the enzymes in their gut to digest protein. So when you have a leaf of a potato plant, for instance, that's complexing amino acids into protein, it becomes indigestible to the Colorado potato beetle larvae. So the way that you get pest and disease resistance is by creating a dynamic where the plant has access to what it needs to actually build higher levels of complexity of compounds in its body. So people may have heard of Phytophthora or Rhizoctonia or Pythium or Alternaria. These are considered to be soil-borne pathogens, and they can't digest carbohydrates. So if you take simple sugars and you have the enzymes present in the plant for them to be complexed into carbohydrates, the plant becomes indigestible to Pythium, Verticillium, Alternaria, Rhizoctonia, these soil-borne pathogens. If your plant is able to complex amino acids into protein, it becomes indigestible to larvae. That would be Colorado potato beetle larvae, or a corn earworm larvae, or a tomato hornworm larvae. All larvae don't have livers. They can't digest protein. When your plant is able to build lipids, fats and oils, it gets that shiny leaf, It becomes indigestible to the blights and the mildews, all the fungal pathogens. When your plant is building these plant secondary metabolites, what causes a tomato to taste like a tomato, or a carrot to taste like a carrot, or a peach to taste like a peach, those things we call flavor are the exact compounds. They're so big and so complex that the beetles can't digest them. So when your plant is functioning well in symbiosis with the microbiome, having access to all the minerals and all the enzymes and everything it needs, it has the ability to become physiologically indigestible to everything except for animals. So I like to say that nature's got a report card. Whether you like it or not, she's talking to you. If she's got bacteria eating your plants, she's telling you you are producing food for bacteria. This is unfit for animals. If she's got larvae eating your plants, she's telling you this is fit for larvae. It's not fit for animals. You can apply insecticides to kill the larvae and harvest the plant and feed it to animals. But those animals are going to get sick, humans, cows, chickens, whatever it is, because it does not have the sophistication of nutrition that animal needs to function. Fungal pathogens, nature's telling you this is fit for fungus. Beetles, nature's telling you this is fit for beetles. So when I was on a farm, growing up as a kid, we had 5-gallon buckets, whatever that is, 20 liters bucket, right? We'd walk down the rows of potatoes. We'd knock the Colorado potato beetles into the bucket. We'd take them and throw them in the toilet and flush them, or tuck them in the wood stove to kill them. And if we did that every 2 days, we probably would get potatoes. And we'd take them and we'd sell them at the farmer's market with our heads held high because we were organic. Little did I know, I was selling people larvae food, right? It may not have been toxic, but it certainly was not of a sophisticated nutritional caliber. And my point now is that the objective of being a farmer is to produce food, not to produce volume. And so that's the insight here, is it works everywhere, it seems like, to work with nature to grow plants that are physiologically indigestible to pathogens. And part of this process, of course, is when the plant's making sugar and injecting it into the soil, taking carbon dioxide and putting it into the ground, you're sequestering carbon, you're building organic matter, you're reversing climate change, right? This process, when you add fertilizer, the plant doesn't need to feed the soil life anymore because the fertilizer is there to suck up, right? Right? You can live on an IV drip. If someone has a car accident and they go to the hospital, they can be fed through an IV drip soluble nutrients into their bloodstream and be kept alive. But that's not how you evolved to eat. Soluble nutrients, fertilizer by definition is a soluble nutrient. It is not a product of biochemical digestion of biological activity. It is a soluble nutrient. So you give a person an IV drip for a week and you take it off. Who was feeding the microbes, by the way? You stop feeding the microbes for a week, your gut flora, right, you're going to have problems pooping, right? Things aren't going to work very well. Right? Just because you're kept alive does not mean that the system by which you were supposed to eat was maintained functioning. Right? So we can be kept alive on a soluble nutrient drip. Plants can be kept alive on a soluble nutrient drip, hydroponics, etc. But that's not how nature evolved it. It's really good business for the chemical companies because they feed you the fertilizer, and then the plants get sick and they feed you the insecticide, and then they feed you the fungicide, right? It's really good business for industry. It happens to be quite counterproductive for nature, unless you're selling pharmaceuticals, which is not really nature. But yeah, I mean, it doesn't just work for the plants, of course, it works for the humans, because when you start to get sick, right, then we're told not to eat good food, but to, we need a drug. Anyways, I'm not going to go on that rant. The point is, it works, it seems to work everywhere, and our thought is, if you can produce food that actually not only heals the ecosystem, but creates better farm viability because the farmers have less pest and disease pressure, less input costs, and the crops have better flavor, better aroma, better nutrient levels, which you can argue have really positive impacts on human health, then by working well with the land as farmers, we can reverse climate change, we can reverse chronic disease, we can suck the life force out of agribusiness, we can suck the life force out of the pharmaceutical industry, right? We can address a number of apparently intransigent existential issues systemically, right? If we just grew food that was food instead of volume. And so that was like 2012 or 2013. I'm like, holy shit. I used to be an activist fighting problems. Now let me focus on building solutions. Like, is there some way we can start to work to build the world we want to see by organizing around food quality? Who's against food being more nutritious? Right? I mean, you're going to have a hard time finding people saying, no, we don't want food to be more nutritious. So you can build a social movement that can have broad-based support around a thing that actually is systemically radical, is the concept here. Yes?
So we need tons of labels that argue this exact point.
No.
Right? Whether they are or they are not.
Absolutely. I'm entirely opposed to labels.
I know, but that's the world we live in, is what I mean.
I don't care about the world we live in. I care about the world we want to live in.
Yeah.
Okay.
So how do you, because you pointed out a few more objective ways, right, to qualify or test the healthiness of certain crops.
Yeah.
Mainly introduce them to whatever you don't want to grow, right, larvae. Do they eat it or not? Other than that, I never heard anything else than a Briggs number, which is I think only about the sugar content.
It's not about sugar, but this is what I'm about to talk about the next 10 minutes.
Okay.
This is where I'm going. This has been the whole lead up. That last 45 minutes was a lead up to what I'm about to talk about now. This was all one big long, like, yes. Good question. So what do we do? What's the plan? Tell us the vision. So, like I said, my parents in the 80s helped write some of the first organic standards in the U.S., right? Like grassroots, before the government took it over in the 90s. And it, you know, like back when it was actually well-intentioned. And I've watched certification labels, bureaucracies, get bastardized, watered down. Right now you can raise chickens entirely indoors, never seeing grass, and they're certified organic. You can grow blueberries in pots with cocoa coir after dosing the land with glyphosate and be certified organic, right? At least in the United States. Maybe it's not quite that bad here. It's
is banned.
in the U.S. You can glyphosate the field, lay down black plastic, put plastic pots, put cocoa coir in the pots or peat moss, and then drip fertilizer into it, and those are organic blueberries or organic tomatoes or organic lettuce. This is what organic is now in the United States. Anyway, the point is, labels are not the answer. Bureaucracy is not the answer. Binaries are not the answer. The quality of the food is the answer, is my argument. And so I don't want to create a system where it can be bastardized. I want it where it can be bureaucratic, where it's about processes. I want a system that's about results. And I want everybody to be able to test for themselves and not have to trust anyone. So the concept basically is you want to be able to walk into the grocery store or the farmer's market, or your buyer, if you're a farmer, who's you're bringing your carrots to, can immediately assess the quality of your carrots with a flash of light, not invasively. So the technology is called spectroscopy, and I've got a little spectrometer right here that we built over the past couple of years. And effectively, the concept here is, I mean, anybody heard about the stars and, like, we know what the stars are made up of?
Yeah.
Yeah.
We do it into a prism, forget the
Light.
Which elements are there.
Through a prism.
Yeah.
Right, so you think of copper as the thing.
Yeah.
Anybody got taught this in chemistry, that copper's a thing, that protein's a thing? Kind of, yeah, right? Yeah. That's chemistry. Yeah. In physics, they say no, copper's a vibration.
Yeah, okay.
So chemistry says copper's a thing, physics says copper's a vibration. So there's an article that came out like last week. I guess it was the, what's that new big telescope they put up there recently?
The James Webb.
The Webb telescope, right? So 1,100 light years away, 1,100 light years away, which is a pretty good distance, they found a carbon molecule, CH3. They identified this carbon molecule in this light system 1,100 miles away. Right? They didn't send a ship out there to go harvest it and bring it back. They took a picture of the light coming off of it, because carbon vibrates at a certain frequency and methane vibrates at a certain frequency.
They get black lines in your spectrum.
So if we can understand what something 1,000 light years away is made up of,
We can do it very close.
we should be able to figure out what something a millimeter away is made up of with the same technology. So spectroscopy is basically that. It's basically you flash a light at something and you take a picture of the light that bounces back and you can see what it is. So our thought was that there is significant nutrient variation in food. And our thought was that it connects to management practices, soil health, fertility programs, consciousness and intention, perhaps, I would say likely, but environmental conditions connect to nutrient levels, And our thought was that you could build a handheld spectrometer that could be used to assess nutrient levels in real time, non-invasively. And so that's the vision. The vision is give people the ability to choose the quality of the food they purchase. If you have something going on with your body, if you have a child who has something going on with their body, if you're just not quite feeling the way you used to, and you kind of think something's wrong with the food, and you want to be able to choose. If you've got 3 bags of carrots to choose from, there's, in the US, we've got Cal Organic, and we've got Bolt House Farms, and you've got Bunny Love. Those are 3 brands of carrots you can choose from. If you've got in the organic milk, you can get Stonyfield milk, you can get Organic Valley milk, you can get I don't know what the other variety of milk is.
Those are brands.
Those are brands.
They're the brands, actually.
Which
for-profit kind of idea.
Right. So the idea is, if you can flash your light at Bunny Love, 20 out of 100. You can flash your light at Cal Organic, 40 out of 100. You can flash your light at Bolt House Farms, 80 out of 100. Which one would you choose?
Well,
Consuming they're all at a relatively similar price point.
In a way.
Damn straight, which is the way the world works.
Otherwise, it's done.
Last I checked, the world works through money. Right? For better or for worse, consciousness, love, empowerment, all these things we all really want and think are important, a lot of decisions get based on economics. And so if we can align economic self-interest with ecological self-interest, with health self-interest, if we can align these things, then we can facilitate a peaceful transformation in some significant fashion.
They're so
let me just...
They're so hinged.
Yeah, I'm just going to make one point. Yeah. That you have talked a lot, and almost everybody else has not.
I'm
so
actually in fucking interest.
I appreciate it, but I'm saying, if give other people a chance to talk too. So I'll just quickly review what we've done in the past 6 or 7 years. So this vision sort of was coalescing, and about 10 years ago or so, I was like, okay, this is like an opportunity to do something significant. How would we do it? And we put these all pieces together. 2016's kind of laid out this vision, like proof of concept. Is it true nutrients vary significantly? Because there's no data that shows anything about ratios, levels of nutrient levels in food. I want to create something that belongs to everyone and can't be controlled. And so, 2017 we built our first meter, portable handheld consumer price spectrometer. 2018 we built our first lab. We had people send in carrots and spinach from across the country, just the US at this point in time. Farmers markets, grocery stores, organic, whatever, not organic. And we assessed only about 12 elements and 2 compounds. So copper, zinc, calcium, phosphorus, sulfur, potassium, polyphenols, antioxidants. And the ranges we found in that first year applied to the future years, so I'll just give you a ballpark of what we found. Say it was carrots, say it was calcium, it was about 3 to 1. As in, this carrot has as much calcium per 100 grams as that 3 carrots. So that's 3x. It's not 3% or 30%, that's 300%. With spinach and iron, it was more like 15 to 1. This leaf of spinach has as much iron as those 15 leaves of spinach. When it was polyphenols, it was 25 to 1. When it was antioxidants, it was 200 to 1. So literally, this leaf of spinach has as many antioxidants in it as these 200 leaves of spinach. Yes?
Would you say it's like looking at this many elements is still quite a simplified view,
yes,
right? Because it's in many different...
That's exactly where we're going.
Ah, okay, great.
Good.
Do you think?
Yes. So, yes, we were just trying to begin to characterize the range of variation. We're a nonprofit, that's an NGO. That means we run on donations. We do not have any investors. And so it was like, can we find $100,000 to set up a lab and run 1,000 samples? Or in this case, it was $250,000. So it was not sophisticated, not complex. It was rudimentary. People know what calcium is. People know what zinc is. People know what polyphenols are, sort of antioxidants they've heard of. And so we're just beginning to characterize the variation, because there's no data set anywhere we've been able to find globally which actually characterizes the variation in the supply chain. We're not doing randomized replicated trials. We're not doing side by side everything the same except for this. No, we're saying, what do people have access to at the point of purchase? That's our stand, that's our question. What is available in the supply chain?
It's a bit of a slightly irrelevant question, but I wonder if you're sharing the data that you generate?
Everything's open source. Everything's on the web. It's been in the commons. Bionutrientinstitute.org. Bionutrientinstitute.org. I'm sorry, I wasn't supposed to take any more questions from you. So, 2018, first 2 crops, first lab. Variations were in the order of 2, 5, 10, 20, 50x, depending on the element or compound in the crop. So not small. The second year of the lab work was 2019. We set up our second lab in California, and we also began to work with farmers to send in the soil the crops grew in, as well as to document the environmental conditions. So what was the variety? Did you till? If so, how deeply? How many times? With what? Did you use fertilizer? Did you use compost? Did you use cover crops? What did you plant? How long were they in for? Did you irrigate? What did you irrigate with? Did you inoculate? Asked a big long series of questions to the farmers, and then we assessed the soil. So top 10 centimeters, next 10 centimeters in triplicate, send in 3 carats, give us the soil here, give us the soil there. We'll look at organic matter, we look at mineral levels, we look at biological activity. So we want to create a dynamic where we can overlay management practices and environmental conditions with soil metrics, with nutrient levels. There were 6 crops that year, similar nutrient variations. And then in 2020, we set up our third lab in Europe, here in France, and we got up to about 22 crops. And we did roots and leaves and fruits and grains. Similar variations in the spectrum of variation of nutrients. And every time we sent a crop to the lab, we flashed a light at it with the meter. So you flash the light at the carrot, and then you put it through the lab and you test the copper and the zinc and the polyphenol level. So we have a spectral signature we can overlay against the nutrient levels. So by the end of the 2020 data year, which was the middle of 2021, we had effectively completed proof of concept. We had shown that nutrients vary dramatically across the board. We had shown that the practices like tillage, like if you don't till your oat field, you have higher levels of organic matter and higher levels of nutrients. If you till your oat field shallowly, 10 centimeters, you have not quite so much organic matter, not quite so many nutrients. If you till your oat field down 20 centimeters, you have even less organic matter and less nutrients. So we found direct connections between management practices, soil health metrics, and nutrient levels, as an example. And we had calibrations with our meter for 10 crops. So this is the little prototype meter here. It's quite rudimentary. It is not testing quality. It tells you one of the crops it's got calibrations for, maybe zucchini squash. And it can tell you polyphenols in zucchini. We have enough data with enough statistical, confidence, and the R-squareds are above 0.8 and whatever the hell all statistical stuff means, that we can say with some confidence, flashlight a zucchini plant, zucchini fruit, it says 64 out of 100, that's where it sits. In that range. There's a confidence interval. So with 10 crops, oats and wheat, actually we had the best calibrations for, which is strange. We've got calibrations for the meter. So we proved, yes, that you can build a handheld, consumer-priced, open-source meter that can be calibrated to nutrient levels, assessed with a flash of light. We've proved that variation is dramatic across the board, and we've shown that the management practices connect to soil health and connect to nutrient levels in the way that the regenerative biological community would like them to. That's 2021. And now we say proof of concept complete. These 3 hypotheses we verified to our confidence, and now we start the job. Now, what the hell is quality? Right? To your point. Because a carrot is a very complex biochemical matrix. It's got all kinds of stuff in it. And we are only talking about minerals and compounds. We aren't talking about energy, which one could argue is actually more important than nutrients, depending on how you think about things. I personally think that the coherence is the important thing, and that Western rational minds have been trained to think about the physical plane and nutrients, but we have not been taught to think about vibration and coherence. So that's a whole other conversation to engage. Right now, we're still hiding behind the Western rational paradigm. So what we're doing now to define nutrient density, this is a term we helped create about 15 years ago to refer to this nutrient variation in food thing, right? Because before, the question was, is organic better than conventional? And it was like all organic is the same and all conventional is the same. Like, what a ridiculous statement. It's like, are all white people better than black people? Or are all women better than men? It's like, well, there's some black people who are assholes and some black people who are amazing. There's some wonderful women and there's some really horrible women, right? Like, you can't just say all one thing is better than all one other thing. That's a ridiculous statement. I'm sorry to use such crass examples, but I think you get my point. So, and also what we found was, you can't predict quality with organic, right? There's exceptional organic and poor quality organic. There's exceptional, grocery store and horrible grocery store. There's great local and horrible local. Like, I can show you some graphs. I got lots of graphs on my computer, and some of the small farmers are not going to want to hear what those graphs have to say, right? The garden stuff is not always better than the grocery store stuff. In many cases, it's worse, right? The stuff at the farmer's market that's local and organic is not always better. In many cases, it's worse than the grocery store conventional stuff because you have farmers operating on scale who are doing a good job. And you have backyard gardeners or organic farmers who are really abusing the soil. It's too dry. It's, the plants are stressed out. Nutrient levels are low, right? So you cannot differentiate based on all these. I would consider them to be dogmatic structures, binary structures. Anyway, where we're at now, what we're doing now is working to define nutrient density. We've chosen beef as our first crop to work on because beef is the crop, think about it as a crop, the foodstuff that which more money is spent on per year than anything else, more than coffee, more than milk, more than corn, more than whatever, sugar. More money is spent on beef than anything else, and also more land is used to produce beef than anything else. And so our hypothesis is, if there's a variation in quality in beef, and the effects on soil health of beef well produced is positive, and the effect on the economics could be significant. Like if we're going to spend a lot of money doing the science, let's target something which can have a significant impact. Cucumbers are nice, but there's not a lot of cucumber production in the world. And if we're really trying to affect human health and environmental health, let's prioritize our efforts on something that could have a significant effect. So, long story short, this is now a global project. We have people sending in samples of their beef, etc., from I think only 5 continents at this point. I don't think we have anything from Asia yet. But we're asking farmers to send in a steak from 3 different animals for triplicate, for scientific, whatever. We're looking at, we started off with about 800 compounds in every steak. So we're looking at enzymes and vitamins and amino acids and lipids and proteins and polyphenols and terpenoids and alkaloids and elements. We want a broad suite of different nutrients. And then we ask for the manure from the animals, and we're looking at hundreds of different species of microbes. We want a biological assay because we understand about poop, and what's in your poop actually can be used to understand how healthy you are or not healthy you are. And then we send in the forage and the soil, and we get management data as well. So this is the project. We're hoping to have our preliminary definition of nutrient density in beef by the end of this year, and at this point, that would be like here's green, here's yellow, here's red. It may not be defined down to the 84, 85, 86th percentile. Maybe we can get to 10, 20, 30, 40 at some point. It costs about $1 million to do the science on one crop. So beef's $1 million, chicken's $1 million, rice is $1 million, cucumbers $1 million. Roughly $50 million will cover most of the significant crops on the planet. Our thought is, if we can do this, if we can raise the $50 million to define nutrient density in food, which in the United States, not a big highway, but a decent sized road costs about $1 million to pave for a mile, right? That's 1.6 kilometers, I think it was what it is. 1.6 kilometers is $1 million. So what would that be? 65 kilometers of road? Do you think we could find somebody to donate to the greater good enough money to pave 65 kilometers of road? Because if we could actually define this, and it's not just what is quality, but what are the environmental conditions, what are the management practices, then we can work with the companies to help them engineer more sophisticated meters than this one is, wherever it is. This is not a sophisticated meter. This is not good enough to look at the nuances that we need to be able to do this job. Our objective as a nonprofit is not to make meters. We do not want to be in the business of selling meters, and this is not good enough. So you can ask for it, I can send it to you, it's not good enough. I'm sorry.
I'll wait for the next one.
She's been waiting, she's pissed at me because she's like, where's my meter? Why'd you send it to me? Like, because it doesn't work. It's a proof of concept. It kind of works on some things. That's all it is.
Or the actual meter itself?
Both.
Okay.
We don't know what nutrient density is on anything, and you can't engineer a meter to test nutrient density until you know what you're testing. It's certain levels and ratios of certain elements and compounds. We don't even know what those are yet. It's original research, right? You have to do the science first without your finger on the scale to figure out what it is that you're talking about before you can move forward. And we're not trying to make money. We're a nonprofit. We're an NGO. The objective is to facilitate collective empowerment through a common knowledge base. And then once we've got that, then we can empower people. We've got, big food companies that are like, hey, you know what? I'd like to know where our supply chain stands. Like, it's one of the things we do is everybody who's taking part in the process, your data is anonymous. I can't see who you are. No one can see, right? If you take part in this project, you get to see who you are, you get to see where you stand, but no one else gets to see who you are. Everyone else gets to see your metadata. Everyone can see your results, they can see your management practices, they can see your microbiome, but they can't see your name, they can't see your address, they can't see your farm name. So the thought is, like, if this is coming down the pike in a couple of years, people might want to know right now where their stuff stands, so that if they see they sit in the 15th percentile, then maybe they can get up to the 50th percentile by the time the meter comes out, because almost everything is below the 50th percentile, right? Like the curves go like this, right? The peak of the curve is between like the 25th and the 45th percentile. 85% of the samples, whether we're looking at zinc or copper or polyphenols or antioxidants, right? The vast majority of what's in the supply chain, organic, local, regenerative, permaculture, all those good names that you think are better, if you look at the nutrients, not looking at the coherence and the vibration, maybe the coherence and vibration is better, but if you're actually looking at the zinc and the copper, they're fairly similar to everything else. So it can be way out here. Your crops can have much higher levels of nutrients, but in most cases, most of what's available does not. And a Brix reading is actually probably the best tool we've got right now to assess it, which is not testing Brix, not testing sugar. Yeah.
If not the labels, do you have some careful suggestions what might be better indicators than the kind of...
I'm assuming that labels will come out at some point that are calibrated to this. I would like to get to a point where a retailer can flash a light at the carrot bag and spit out a label onto the bag 85, and flash one out here and spit out 45. Most retailers aren't going to want to put a label on the bags of stuff they've got, because almost everything is 35, 40, 45, right? So what I want anybody in the world to be able to test for themselves. If we've got that, if we have the ability for everybody to see for themselves empirically, transparently, and be empowered to discern, they don't need to trust marketing, they don't need to trust labels, they don't need to trust anything else. They can go and see for themselves.
What do you predict when these would cost?
This one right now we've been selling for $377. There's no reason why it couldn't be one of the cameras in your smartphone, right? Apple's looking for a really good reason for people to buy the iPhone 37 or whatever it is, 16, 17. Like, can you imagine? Would you buy a new smartphone if you could? Boop, 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 boop. I think people would, right? I think people would. So, yeah.
How stable is that number? Does it fluctuate over time? Because we're talking about living or dying in this case.
So it is true that compounds degrade over time. Right? If you harvest a carrot today, the level of polyphenols in it in a week will be lower. The question is how much lower, based on how you keep it. If you keep it in the proper temperature and humidity conditions, you can maintain that level over quite some time. In general, we see the crops with high levels of nutrients have longer shelf lives. They take longer to degrade. My basic point is, if you pick a carrot and it's 9 out of 100, you can do perfect temperature and humidity maintenance for it, and 3 weeks later, it's still 6, right? Which is not particularly impressive. So you only be picking at 90, and then by the time it gets to the market, it's at 85 or 80, right? So the opportunity here is to just have a rising tide lifts all boats. The mission of our organization is to increase quality in the food supply. Our mission is that next year, the average level of nutrients in food is better than it was this year. We want the overall supply chain to have higher levels of nutrition in it, because we think that will correlate with any number of systemic issues being addressed. Personally, what drives me is the perhaps more deeper internal esoteric aspects of things. I'm of the opinion that we all have a spiritual nature, a higher levels of consciousness, subtler aspects to our being. in the science of the East. People heard about the science of the East? Like we do physics, they do metaphysics. Anybody know about yoga and tantra and Vedas and chakras and nadis, and anybody know about that stuff? Energy bodies, heard about it? Some people don't believe in it. That's fine, your business. Indigenous cultures globally tell us that we have the capacity to communicate with nature. Anybody hear about this one? You go to the Amazon and you ask, the anthropologist asks the tribal people there, like, how the hell did you figure out that this root plus this leaf equals this effect? They're like, because they told us, duh. How else would you figure it out? Right? You talk to the Maasai in Central Africa, same question, same answer. Ask the Aborigines in Australia, same question, same answer. Ask the Westerners, they say, no, it can't be done. So if you are a scientist, if you're a scientist and you got 15 data points, 14 are on a line, 14 cultures say globally, who are not talking to each other, all say the same thing, and one culture says that's not true. If you're a scientist, right, not a dogmatist, but a scientist, you'd say chuck out the outlier. Right? I'm of the opinion that other cultures have insight about our deeper nature, and my opinion is, I think even the Western scientists will talk about this thing called dark matter, dark energy. Anybody hear about dark matter, dark energy? Heard about it?
Yeah.
Wait, we don't know what it is? It's like 98% of reality? 95% of reality? 98? We can't find. All the telescopes, all the microscopes, right? All the tools of Western science, the physical plane, all the physical plane we can find is 2% of reality. That means 98% of reality is not on the physical plane. Doesn't mean it doesn't exist. It just means it's not on the physical plane. So I use the metaphor of the piano keyboard. Anybody here? You know what a piano, right? Yeah. So you got the octaves, right? You got low, low C, you got C, you got low C, you got C, you got high C. These are octaves. In my mentality, the physical plane is one octave. And there's other planes of reality that we actually have the capacity to engage in. If anybody's done anything with meditation and yoga and stuff like that, you maybe have felt your chakras. You maybe have felt sensations that were not physical. Have you ever felt love before? Love, right? Not a physical sensation, but certainly a real thing. Really cute, sweet kids, but it doesn't sound very good, right? Whereas if you go to listen to the a cappella choir singing perfectly in tune, 4 voices, you'll hear a 5th note. A harmonic will be sounded. A higher octave becomes manifest when this octave is perfectly in tune. So I like to suggest that DNA is a thing in chemistry but a vibration in physics. That hormones are a thing in chemistry but a vibration in physics. That every single person has a vibe. You have a more coherent or a less coherent vibe. Like, if it's really hard to tune into your higher nature, it's very hard to have your harmonics of consciousness be grounded in your being if you're vibrating incoherently. So I'm of the opinion that most of the structures of culture are made by humans. The political system, the economic system, the media system, the education system, agricultural system, the medical system are made from people. People are the ones in those systems, and generally they mean well, but generally they're relatively out of tune. And if you've got a bunch of dissonant people engaging in the medical system, you're not going to have a coherent medical system. So my thought is, instead of fighting pharmaceuticals, or instead of fighting agribusiness, instead of fighting the media, instead of fighting the political system, instead of fighting the economic system, we do the spiritual covert op, which is that we help people build more coherent bodies. If you get a new body every 6 months, most people eat most days, right? If people begin to build more coherent bodies, they will then therefore become more coherent, and their effects on the world will then become more coherent. I think we can solve a lot of the world's problems by simply producing good food. So I'll stop there.
Big applause. Thank you so much. That was amazing. I mean, this man is really speaking truth and simply telling that good food is the key to solving our issues. And for the happy news,
I think eating it with friends, and there's all kinds of food. There's physical food, and there's emotional food, and there's intellectual food, right? So if you're watching, I don't know, Fox News. You ever have Fox News here? You got something else? You know what it is. How about Facebook? You gotta know what Facebook is. Yeah, you know what it is, right? And you, I mean, you understand how we're manipulated, guided to have angry thoughts, right? I would say an angry thought is a dissonant vibration. And if you are a vibrating liquid crystal and you're engaging in angry thoughts, you are eating dissonance. So it's not just about the physical food. It's about our emotions, our relationships, our thoughts, to get to the deeper level of what food is. So eat good,
all those foods.
Eat high quality food, and while you're angry at somebody alone, is entirely different than eating high quality food when you're loving people in community, right? So it's really a whole thing as far as I'm concerned. It's not just the food itself, it's a deeper systemic conversation. But I only had an hour.
Absolutely.
So
Thank you so much. Yeah, I would just,
I go for another 10 hours.
As a break, I would just like to say, amazing. There is some wonderful food.
Yes, it's supper time.
And
Perfect.
ready.
And
So
you can
let's
enjoy
eat
it with
the
wonderful people.
physical and emotional and the
Yes.
spiritual food. It's prepared by wonderful neighborhood chefs from the neighborhood, so enjoy. And yeah, if there's any more questions, and then are you willing to talk more about
I'm around.
healthy food?
Yeah.
Great, then
Yeah.
hit it up. Thank you all, and thanks, Dan.
Yeah.